right, my friends, 85, there's more than one way to do it. I was going to show both methods, but I've decided that I'm probably just going to show the shorter way. And if it doesn't make sense, then you're welcome to ask me about it, and I can show you the longer way. So it says the fuel consumption of a car in miles per gallon is modeled by F of S equaling big mess. So for me, you know, with stuff that has some reading comprehension, I have a tendency to just kind of like label things. You could write the rule or not, but I think I'll just say like big F just means miles per gallon. Where S is the speed of the car, so S is speed of car. It's just kind of nice to know, I think, what's what. In miles per hour, the car is traveling at 50 miles per hour and its speed is changing at a rate of 20 miles per hour squared. What is the rate at which its fuel consumption is changing? Okay, so let's see. What is it that we want and what is it that we have to work with? Okay. So they want to know the rate at which the fuel consumption is changing. Well, this is the fuel consumption right here. So if they want the rate at which it's changing, that would just be ddt of this, if that makes sense. So we want ddt of this right here. And then what is it we have to work with? They said the car is traveling at 50 miles per hour. So that would mean S is 50. Now, not constantly. S is not constantly 50. S is instantaneously 50. So make sure you don't plug 50 in right now, because then you'll get your answer to be 0. The answer is not 0. And then its speed. Okay. So, and then its speed is changing at a rate of 20 miles per hour. So that would be ds dt is 20. Okay. So again, not constantly, but instantaneously. So we want this at this moment, if that makes sense. So, or maybe I should say it like that. We want this at the moment that S is 50 and that ds dt is 20. Then I don't even need the half section. I could just erase it. Okay. But hopefully what it is that we're looking for, hopefully this part makes sense as far as how I got that. So now, and the longer way would be to deal with like the rule and take the derivative by hand, but this is the calculator section. So let's make that calculator be our beast of burden, shall we? So let's just figure out what would ddt of big F of, you know, of S be. Well, you'd have to take the derivative of the outside function. So you'd have to, you know, take the derivative of this function right here. So I'll just say, I'll call it f prime, even though you could also call it lowercase f. And then you'd multiply that by the derivative of the inside function. And so, and the speed is a function of time. So you need to make sure you use chain rule here. So you'd multiply by ds dt. And then once you have that, you just need to plug in 50 for S and then, you know, 20 for ds dt. There you go. So that's what I'm going to do. You know, I've already typed in this rule for y1, and so I'm planning to take its derivative and then multiply it by 20. And then make sure I plug 50 in, which your calculator will do all of that. So, so basically what I'm going to get now is with my calculator, it's going to give me, so f prime, whoops, that's a funny little prime. So I'm going to make my calculator do f prime of 50 now. So take the derivative of that function with respect to x and plug 50 in. And then ds dt is 20. So now I just need to multiply that by 20. And there you go, approximately 4.299.